Good morning students. Let us see a problem related to your riveted joints. So a double riveted lap joint. So here we have a double riveted. So double riveted lap joint is made up of 15 mm thick plate. So here 15 mm means your T is equal to 15 mm thick plate. Next, the diameter, the rivet diameter and pitch are what? 25 mm and 75 mm respectively. So the pitch and the rivet diameter, that is rivet diameter is 25 mm and your pitch is equal to 75 mm. Next, if the ultimate stress is 400 mm, so we have ultimate stress that equals to 400 mm, that is your tensile in tensile, and 320 megapascal in shear. So your tensile is equal to tensile ultimate is equal to 400 megapascal and shear ultimate is equal to 320 megapascal, that is also written as 320 Newton per mm square. So 400 megapascal as 400 Newton per mm square. Next, and 640 in crushing. So ultimate crushing stress is equal to 640 megapascal, that equals to 640 Newton per mm square. So what we have to find out? Find the minimum force per pitch length. So you have to find the minimum force per pitch length which can rupture the joint. So we have to find the minimum force which can rupture the joint. And next, what we have to find? If the above joint is subjected to a load such that factor of safety is 4. So if the above joint is subjected to a load, certain load, and the factor of safety is 4, then what you have to find? Find the actual stress developed in the plate and rivet. So you have to find out the actual stress and developed in the plate and your rivet. So first you have to find the minimum force per pitch length which will rupture this joint. So for finding out that, we have to find out the ultimate tearing resistance of the plate per pitch length. So this is given by the formula, as I have already explained in your previous videos, that ultimate tensile resistance, tearing resistance of the plate per pitch length is equal to what? P minus D into T into sigma TU. So P is your what? Pitch, D is the diameter, T is the thickness, and TU is the ultimate tearing stress. So 75 minus 25 into your thickness 15 into 400 is your stress, ultimate tensile stress, that is your 3, we are getting 330,000. Okay. Next is your what? Ultimate shearing resistance. So ultimate shearing resistance per pitch length, that is equal to what? PSU. So this is given by formula N into pi by 4 D square into tau U. So here you have seen double riveted. So N is here what? 2. Next, 2 into pi by 4 into your diameter is 25 whole square into your shear stress, that is equal to 320, that we are getting is what? Answer 314200 Newton. Since N is equal to 2, we are putting 2. Next is the ultimate crushing resistance of the rivet per pitch length, that is equal to what? N into D into T into sigma Cu. So that equals to 2 into 25 into 15 into 640, that is equal to 48,000. Sorry, 4,80,000. So next, from the above, which is the minimum? So from the above, which is the minimum? This is 30 and this is 3142000. So this one is 3,14,000, 14,200 Newton, and this is what? 4,80,000 Newton, and this one is what? 30,000. So minimum is what? 30,000. So from the above, minimum force per pitch which will rupture the joint is your what? 30,000. Next, so next we will go safe load per pitch length, that equals to your, here I am missing one zero, here this one is 3 5 zeros. Okay, so this one is 3 lakh, this is one is 4 lakh, and this one is 3 lakh 14,200. So minimum is your this one 3 5 zeros. Next, as you know, factor of safety is 4. Therefore, safe load per pitch length is equal to what? This load, this one, this 300 kilonewton, that is your 3 into 5 zeros divided by your 4, that we are getting safe load, that equals to 75,000. Next, let sigma TA, tau SA and sigma CA be the actual tearing, shearing and crushing stresses produced with a safe load of 75,000. So tearing, shearing and crushing, actual we have to find out the resistance. So actual tearing resistance of a plate equal to what? PTA. So PTA is given by the formula or by what? Pitch minus D into T into sigma TA. So you know this one as 75,000 safe load. So 75,000 is equal to this much. So putting the values of T, P, D and T, we get what? 75 minus 25 into 15 into sigma TA, that equals to 750. Sigma TA is equal to 75,000. So sigma TA is what? Actual tearing stress, that equals to 75,000 divided by 750, that equals to 100 Newton per mm square. Next, similarly, actual shearing resistance, that equals to PSA, so that equals to 75,000 equal to your the formula for tearing resistance, shearing resistance, that equals to N into pi by 4 D square into tau SA. So as N equal to here 2 into pi by 4, D is equal to 25 square into sigma SA. So what we are getting? Sigma SA as 920, 982 sigma A SA. So sigma SA is equal to 75,000 divided by 982, that equals to 76.4 Newton per mm square or 76.4 megapascal. Next is your what? Actual resistance for your crushing. So actual crushing resistance for rivet is equal to PCA. So putting the formula of your crushing resistance, that equals to N into D into T into sigma CA, that equals to 75,000 equal to here N equal to 2 into diameter 25, thickness 15 into sigma CA, that equals to 750 sigma CA. Okay, this one is 750 sigma CA. So sigma CA equal to what? 75,000 divided by 750, that equals to 100 Newton per mm square. So here we are getting what? When it is subjected to a safe load of factor of safety 4, so different actual stresses developed in the plate are your 100 Newton for your tearing, 76.4 for your shearing and 100 Newton per mm square for your crushing. Thank you.